Okay, today we are going to see the polymer topic. Mainly, the first thing we are going to see is what are polymers. All of you know that the polymers means poly means many and mers means the part. Okay, so polymer here stands for poly means many and mers means a part. So, the polymer means can be defined here as it is a, we can say that the molecule high molecular weight substance which are formed by the smaller molecules, okay, and these smaller molecules are also known as the monomers, okay. So, we can again define it as polymers are nothing but formed by the different numbers of monomers which are linked together to give the high molecular weight substances. Okay. Now, the next part in a polymer that we are going to see is a functionality. Okay. For the example here is a polyethylene. This is a ethene monomer, clear? So, this ethene molecule monomer when taken n times can give you a polyethylene, which indicates that this monomer is being repeated n time number. Okay. So, this is our monomer and this is our polymer. Monomer is just a ethene molecule where this ethene molecules is repeated n number of times, that time it becomes a polymer. So, the next part is a functionality. Now, we can define the functionality as well, that it is a reactive sites or the we can say functional group present in a monomers. Okay. So, functionality, number of reactive sites or we can say the functional group in a typical monomer. Clear? Now, according to the functionality, our monomers can be defined or can be classified into three different types. The first one is a bifunctional. As the name suggests you over here, bifunctional means there are two functional group or two active reactive sites over here. Okay, that is, for example, we can take ethene molecule. So, these two are the two functional group from which we can extend our polymer chain. So, these are the two positions that are the active sites from which the polymerization can take place, hence it is known as a bifunctional group. The next one is a trifunctional. In case of a trifunctional, again there are three we can say reactive sites or functional groups. For example, we can take over here is a glycerol. Okay. So, you can see that CH2OH, CHOH and CH2OH. So, these are the three active sites or we can say the functional groups where the polymerization can take place. So, we can say that if in a monomer there are three functional groups, so it can be termed as a trifunctional. Okay. Then the third one is a tetrafunctional. Okay. For example, over here is a butadiene. So, in butadiene, there are four different reactive sites or four different positions from which there is a polymerization taking place. Okay. Hence, it is termed as a tetrafunctional. So, all of you now clear with the what is a functionality. So, we have termed it as a number of active sites or functional groups present in a monomer, and according to that we have classified into three different types, that is a bifunctional, trifunctional and a tetrafunctional. Okay. Clear it? The next part that we are going to see is a polymerization. Okay. Now, how to define polymerization? Polymerization is a process by which we combine a monomer and the new polymer is formed. So, this process is known as a polymerization, from which monomer is converted into the polymer. Okay. So, polymerization is simply conversion of monomer into the polymers. Clear? Example, again we will take ethene. This is a monomer. So, this monomer when taken for n number of times can be converted into polymer. Okay, this indicates n number of times, that means repeating units, and this is the extension. Clear? So, the next point that we are going to see is a degree of polymerization. Okay. Now, degree of polymerization is defined as it is the average number of repeating units present in a polymer. Okay. So, degree of polymerization is the average number of monomers present in a polymer. Clear? So, we can also say that there is a relation between a degree of polymerization and a properties of a polymer. That means with the increase in a degree of a polymerization, there is also an increase with the increase of a temperature and time. Okay. So, we say that degree of polymerization increases with the increase of time, temperature as well as concentration. So, this is a relation between time, temperature and concentration with the degree of polymerization. Clear? So, the average number of monomers are at least, they should be at least 20,000. Okay. So, average number should be at least 20,000 to have the properties of a polymer. If we want the properties of a polymer to be existed, the average number of degree of polymerization is 20,000. Okay. The next point that we are going to see is a classification. This is again a very important point, classification of polymerization. Because as we know, the polymers can be classified in a different ways. So, the 4 different ways that we are going to see this year are, the first classification is a sources, that is availability of a sources. So, the polymers can be classified on the basis of a sources. So, the first source, quite obvious, it is a natural source. Okay. And second one is a synthetic. Now, all of you are well known of a natural sources. Natural sources are what? Cellulose, starch, these are the natural sources. Again, we can say that natural can be classified into 2, that is from a plant as well as from animals. So, from plant we get is a cellulose starch. From the animals we say the polymer which is obtained from a animal source is a RNAs, DNAs are the nothing but proteins, nucleic acids are again a natural polymers. The second one is a synthetic. Okay. We will write here example, cellulose. For the synthetic, it is a man-made polymers which are synthesized in a laboratory. For example, it is a nylon, polyester, polythene, all these things are a synthetic polymers which are having a numerous, we can say, applications, and they have a numerous importance. Okay. The second classification is based on a structure. Okay, now the second classification based on a structure means what kind of a structure does the polymer possess. Okay, so the first here is linear polymer. All of you know, very well example is a polyethylene. Okay, so the linear molecule will give you such kind of a polymers which are in a straight chain. There is no branching, no cross linking, nothing. It is a straight chain, hence it is known as a linear polymer. Okay, very simple one. The second one after linear is branched polymer. Here we get polymers of branching type, okay, branched chain. So such kind of a polymers are obtained over here. That means here it is a completely straight chain, here we get a branch to the chain, okay. So hence it is termed as a branched polymer. And the third one is a crossed linked polymer. Okay. So the cross linked polymer are where there is a formation of a bridge between the two chains. We can say this is a cross linking polymer. This is a cross linkage. So there is a kind of a bridge formation. Okay. So hence it is termed as a cross linkage. Linear polymer, branched and cross linked. Clear all of you? So thus we completed a classification of a sources according to sources, then according to structure, and now third that we are going to see is as per the molecular forces. So the classification based on a molecular forces. First one it thermoplastic. Thermoplastic polymers are those which get very softens on heating and again it get hardens on cooling. Okay. So it soften on heating and get harden on cooling. So this is the property of a thermoplastic. Exactly opposite property is of a thermosetting. These kind of a polymers do not get softened on heating, otherwise we can say that they lose or they get undergoes a permanent change. Okay, so the permanent change is observed on heating. Clear? So this is our thermosetting. The third one is elastomers. Now the elastomers are the one which possess elasticity in them. Okay. For example, very well known example is a rubber. So this is a kind of a polymer only, but they have the elastic property in them. Clear? And then last one is a fiber. This is an example fiber. For example, it is a nylon. Clear? So we are classifying the polymers, third type of a classification based on a molecular forces. The first one is a thermoplastic, thermosetting, elastomers and fiber. So this we completed the third classification. Now the last classification is based on a modes of synthesis, and again I tell you this is very important, modes of synthesis. According to the modes of synthesis, our polymers are classified into two. First one is the addition polymer and second one is a condensation polymer. Okay. So we will see first addition polymer. It is simply addition of a different monomers. Example, polyethene, this is a ethene molecule which is a monomer, and on addition of a several ethene monomers together will give you a polymer. Okay, so this is a polyethene, and this kind of a reaction or this kind of a polymers which are formed by such type of a step where there is a no elimination of a byproduct, that time we say that it is a addition polymer. And the second one is a condensation polymer. The only difference that you have to keep in mind is in addition polymerization there is no elimination of a byproduct or a simple molecules like a water molecule, HCl. Okay, so this kind of elimination is not there. Now in condensation, for example, we will take this is adipic acid. Okay, this is a hexamethylenamine and this is a adipic acid. So there is a elimination of a water molecule, the OH from this, okay, OH from this adipic acid and the hydrogen from this molecule. So it will eliminate a water molecule, and because of elimination of this water molecule, there is a, we term this reaction as a condensation reaction. Otherwise in addition reaction there is a no any kind of a elimination. Okay, so the product you will get here is a nylon 6,6. So this is a product that you get. Okay, this is our nylon 6,6. So this completes our modes of synthesis. Okay, so we say that modes of synthesis are two. One is addition polymerization, another one is a condensation, and we have seen the example as well as the reactions. All of you clear with this? Okay. So just we will revise the things that we have seen. We have seen the functionality. We have seen the definition of a polymer, functionality, the types of a functionality, that is a bifunctional, trifunctional and tetrafunctional. Then we have seen the degree of a polymerization, which is a average number of a, we say average number of a monomers that are repeated in a polymer, that is our degree of polymerization. Next is a classification, and the classification we have seen of a 4 types. First one was the sources, then based on a structure, then the molecular forces, and then modes of synthesis. This completes our polymers. Thank you.